right, so let's go over our review for first law first. An object at rest will remain at rest. An object in motion will remain in motion with a constant velocity. Important, don't just say speed, because speed might mean that it's turning, and if it's turning, it is accelerating, which would be not the first Newton's law. It would be a second Newton's law. So when you're saying first Newton's law, that you are referring to your net force. So all forces balance each other out, therefore net force equals 0, then velocity equals constant. You could say at a constant speed in a straight line if you want, but saying constant velocity basically encompasses everything, including rest, because velocity can be at 0. Is force of gravity, which, remember, g is non-gravity, g is 9.8, which is acceleration due to gravity. Here's your force of gravity. This is called gravity. Mass times g equals gravity. So that box is being pulled to the right with 15 newtons. And I also know that the force of gravity is going to be straight down. So I'm going to get myself a center. And I have my force of gravity that away. Equal to it will be my normal force. And then I have being pulled to the right with 15 newtons. 15 newtons. And then since it is not moving, that tells me then there is a force of friction which is equal. And I can say force of friction static if I want. That is equal to 15 newtons. So rest. Therefore, I know that my force of friction equals my force of pull. And then my mg equals my force normal. So if I want 5 times 9.8, which will be my 49 newtons, that will be my force of gravity and normal force, since it's asking me to find the forces acting on my box. We have a skydiver who's moving at a terminal speed. Remember, terminal speed means that we have equal forces. And since this is in real life, then we have force of gravity obviously going down, and then force of air resistance equal to it. So my force of air equals to force of gravity because V is constant. Now, I don't know my force of gravity, but I do know 686 newtons is my force of air resistance, so I can just say both of them are 686, and therefore, since I'm after mass, I will take my 686 and I will divide it by 9.8, and that should give me 70 kilograms. Next, example 3, we have a 45 kilogram container pushed at a constant velocity. Again, constant velocity tells me that the forces are balanced. So I have my force of gravity down, force normal up. So I can say force of gravity equals force normal balanced out. So it's going to be 45 times 9.8. That is my force of gravity and force normal. And then as far as it's being pushed, and they don't tell me which way it's pushed. So I'm going to just say this is my force of push. And this is my force of friction. It's going to be kinetic because it's at constant velocity. Example 4 and 5. My CP students, you can take a break. We have an incline and force of gravity is still straight down. Here's my force of gravity. Remember, because of the incline now, force of gravity will have 2 components. This is my mgx. And this is my mgy. Mind you, these are not real forces. I'm not drawing actual vectors. Then my mgy is supported by normal force, force normal, which is equal to mg cosine of theta. If this is theta, which is 30 degrees, then it's over here as well. This is my 30 degrees. I can do 25 times 9.8 times cosine of 30. Will be my normal force. And then what else do we have? It is resting, which tells me that there is one more force, because right now the way I have it, it's going to be sliding down like no tomorrow, accelerating. Since it's resting, then it's going to be force of friction static, and it should be exactly, so force of friction static is going to be mg x, and it's going to be 25 times 9.8 times sine of 30 degrees because it is at rest. All right, then example 5, v that equals constant. So it's sliding down, that sled is sliding down this little 15 degrees at a constant velocity. So again, I will say that my force of friction, in this case kinetic, will be equal to mg times sine of 15 degrees. So if I wanted to calculate, I will take my 42 times 9.8 times sine of 15. That will be my force of friction, kinetic, since it's sliding. And then I also have my force normal, which is balancing my mgy. So I will say that normal force is going to be 42 times 9.8 times cosine of 15 degrees, because again, if 15 degrees is right here, then in this little triangle it is up here, and this is my mgx, and this is my mgy. Mgy is supported by normal, and mgx is supported by force of friction. It could be kinetic, it could be static. Again, all of this was for Newton's first law, is when we have balanced forces, then we know that our object might be at rest, or if it is moving, it's moving with a constant velocity.